When I finished college in June 1956 and went to work in the motive power department of the N&W, I was given the title of shop inspector and assigned to the Schaffers Crossing roundhouse. The N&W was 100% steam then, including steam turbine electric N&W 2300, John Henry. One of my assignments was to handle the broken parts reporting. Either the foreman would notify me of a failed part removed from some steam locomotive, or else I would tour the roundhouse to find any broken parts removed on another shift. I would use a report form to describe the nature of each failure to the N&W physical lab, and hold the part until I heard back whether the lab wanted to inspect it. I began to notice that an inordinately large percentage of the broken parts that I found had been removed from Class Y6 locomotives off the Roanoke-Hagerstown part of the Shenandoah Division. When I mentioned this to one of the more experienced shop inspectors, he told me that it was because the engineers on the north end ran the Y6s up to 60 mph there. This figure is what my feeble mind seems to recall, he told me, obviously putting more stress on the reciprocating parts, such as the valve gear components. So, my information on Y6 speeds on the north end of the Shenandoah Division agrees with what Rick and Mason describe. This brings to mind another Y6 maintenance problem that I observed as a shop inspector during the summer of 1956, but one that doesn't seem to be well known based on some conversations that I have had with knowledgeable N&W locomotive historians. What is generally well known, and chronicled in Bud Jeffrey's book on N&W steam locomotives, is that the N&W in 1953 to 55 poured some 14 tons of lead in the low-pressure engine frames of Class Y5 and Y6 locomotives to take advantage of the increased tractive effort afforded by the application of booster valves that admitted some high-pressure steam into the low-pressure cylinders at low speeds. What I saw in my rounds of the roundhouse was an occasional Class Y5 or Y6 shopped because of a low-pressure frame crack in the upper corner of the pedestal opening caused by the extra weight of the lead, so I was told. The procedure was to spot the wheel set that was in the cracked pedestal over the roundhouse drop table, remove the rods connected to that wheel set, drop the wheel set and move it to the drop pit release spot to stow the wheel set, and return the drop table to the roundhouse floor level. The welding supervisor at that time was Curry Neese, and one of his men would take an acetylene torch and cut out the full length and depth of the crack in the frame. I would guess, based on my recollection now, that the width of the cut was at least an inch wide. The welder would then take a stick electrode and slowly fill in the cut groove with weld metal, finishing the job by grinding the weld metal flush with the frame surfaces. This was a case of 10 steps forward and 1 back. The forward steps were the increased performance with the booster valves, and the back step was the occasional cracked frame. I don't recall that there was an epidemic of cracked frames, but they did occur. Gordon Hamilton.